Trying an AI to understand complex maths or coding problems usually ends up in hallucinations or broken code. But today we have a massive LongCat 2.0 model which is 1.6 trillion parameters big and also only activates 48 billion parameters while doing any predictions, keeping things highly efficient. Today I'm going to be doing a full technical breakdown of this new model and also going to be testing this on 3 different technical tests just to check all of its capabilities. What makes this really special is that the creators have completely skipped out the NVIDIA chips, which are being popular in all of the AI models right now, but they have instead gone for the superpods architecture, where they have made their own custom AI chips grouped together in different chunks. And the model that they have built is having a 1 million context window, which means it can take a massive amount of textbooks or your entire code bases directly into the memory and then do any kind of processing or projects that you want to build on top of them. This is possible because they have introduced this LongCat sparse attention in this new model, which basically means that it will not look at the whole training data and instead only focuses on the relevant information. They have also trained this model on a massive hundred of billions of tokens and also have done dedicated post-training which gives this new model strong performance on coding and agentic tasks. If you want to know what this sparse attention means, the model basically takes top k selector and instead of reading every single piece of memory, it will only pick the top k ones which are relevant for the current context. And the real magic in this architecture diagram is this arrow which says that it directly reuses the indices from the owner layer, which means the future layers do not recompute every kind of attention mechanism, but simply use the memory map of the earlier layers, saving a massive amount of computing power. And while training this model, they have also saved a huge memory layer problem with this streaming-aware indexing, where they combine the hardware-aligned contiguous text blocks, and instead of taking the small broken chunks for each of the training step, the hardware reads the whole memory in smooth continuous tracks, making the whole process really smooth and memory efficient. And for ultra-long documents, it uses a clever two-step guessing game, where it first look at the big blocks of the text to find the general area of the answer, and then the fine-grained token selection will zoom in on that particular area and pick the right exact words for the next prediction tokens, which drastically shrinks the overall workload of the processing memory. To make the model even smarter without making it heavier to run, they have introduced this n-gram embedding blocks, which makes the AI to learn the word combinations instead of just the single words, expanding its understanding of context by about 1000 times. They have put the n-gram size to 5, which basically means they will have 5 different layers of the n-gram blocks, letting the AI to group together 5 words at a time and process them at a single block to understand the local meaning perfectly. And this basic architectural diagram of n-gram embedding also shows that the base embedding works with the n-gram blocks to finally make a super rich embedding vector. If you don't know what embedding means, it just means that the words will be converted into numerical numbers so the AI can understand them, and vector just means the array of numbers that the AI will be able to process. The words are converted to these embedding vectors such that if 2 similar words are there, then their vectors will also be similar. So whenever the AI is making any correlation between 2 different vectors, they will be able to understand these 2 words mean the same thing. They've done a lot of testing to ensure that this n-gram model does not take over the whole model. They basically found out that if they keep the special parameters less than 10% of the overall budget, this will give them best results and also keep the memory reading fast during the generation process. Training this whole model was also a huge task because they had to use 50,000 AI custom chips for the whole training process. Since the software of these chips wasn't as mature as the NVIDIA chips, they had to build a completely custom stable setup from scratch. And because these custom chips have a lot less memory than the standard NVIDIA chips, they had to use a special technique called bit flip detection. This is like a random bit flipping from 0 to 1 during a mathematical process. They had to write custom codes to instantly detect these anomalies caused by these hardware bit flips so the training wouldn't get ruined by a random mathematical error. And because of this same memory limitation, which was the primary bottleneck of the training at scale, they had to switch the parameter into 6 different blocks and train them all in parallel manner, which ensured that all the experts and the n-gram models can run smoothly across the whole cluster. And to train the model how to read a massive data of 1 million context, they had to invent a new way to share the workload. They just reshuffled the data right as it entered the training system, balancing the heavy memory load equally across the 100 of custom chips. And they carefully designed the system so there is a significant communication overlap between the chips and the compute. So while the one part of the chip is doing all the calculations for the attention, another part is secretly grabbing the next bench of memory in the background. Now if we look at the official benchmark numbers compared to the other frontier AI models, the results are really impressive. If we look at the SWE Benchmark Pro dataset, which tests the real world software engineering. This open source model is scoring at 59.5%, beating out the heavyweights like GPT 5.5 and Claude Opus 4.6. Just the latest Opus 4.7 and 4.8 is able to beat it, which shows that open source framework is really progressing at incredible speed. As on other benchmarks as well, it is able to perform at par with the frontier AI models. Now I'm going to be testing the main capabilities of this new model by giving it a large Microsoft investor annual report. For testing, I'm going to be using the free online chat version, but you can also go for the API access, where you will be redirected to the API platform docs, having step-by-step method on how to set up the API key. And there are also ways how you can integrate this LongCat tool into your direct coding agents like Claude Code, Kilo Code, OpenClaw, OpenCode or Codex. You can also check out the open weights by clicking on Hugging Face, which will redirect to the 1.6 trillion parameter weights. But just keep in mind that as it is so big, you will not be able to run it on consumer hardware. For now, for testing, I'm going to be clicking on this try it button, which will redirect me to this longcat.chat window. Here I will give a simple prompt that read through the annual reports of this company, compare the numbers and text across all the years to find any hidden memory problems, lawsuits, or bad business trends, and also list out the biggest warning signs. Now I will attach the Microsoft annual report that I have just downloaded, and I will click on the submit button. So now it has given the warning signals that there is a customer concentration risk, a talent dependency, then OpenAI relationship complexity, then there are geopolitical risks of US-China tensions, then integration risk from the acquisitions, and additional metrics to monitor. And then finally, it has given the conclusion from the final annual report as well. So we saw that it was able to do a complete analysis on the 100-page report that I had given to it, proving that the 1 million context capability is actually working. So that was the complete breakdown of the LongCat 2.0 model. Drop a comment if you have some more suggestions for me to build such new AI models, and follow the channel for more such AI builds, updates, and workflows.